Azure Storage Service, a completely new service is what we want to begin from here now. We are going to talk about majorly how the data gets stored and managed by Azure when it is in very large volume. So yes, we will see about it's a pretty lengthy chapter actually. We are going to cover what exactly is a storage service, how do we create a storage account, and in storage service we have got further four categories: blob storage, table storage, queue storage, and file storage. Of course, together with that, we are going to see what exactly is CDN, how can we make our storage secure. We are going to see programming storage through PowerShell, programming storage through code, C Sharp code. All these things one by one we are going to cover in next few sessions now. So what is a storage service and what is a storage account? See, when we talk about any application, it has logic and it has data. These are two common things, logic and data. And of course, logic always operates on the data, and that's what is application all about. But there are certain extreme situations where there is huge amount of data which we need to manage. Data which doesn't stick to only KBs and MBs, or it goes into TBs actually. So when we want to manage TBs of database, pretty obvious something like SQL Server database will not be sensible. I would not be able to put large, huge TBs of data in SQL Server and manage that easily. It's going to be pretty expensive also in terms of cost and also in terms of performance. So this is the place where precisely SQL storage is going to come into the picture. So cloud computing enables new scenarios for applications which require scalable, durable, and highly available storage for that data. Now, scalable, what does it mean? We want it to increase its capacity as and when needed. The scalable factor is that. Durable, by any chance, if something goes wrong at one place, durable and highly available basically. I still don't want my data to be lost. Basically, I should be able to maintain multiple copies of my data. That's how I will make it as durable and available, highly available. Storage service provides these three major features: scalability, durability, and availability. Now, what is the type of data we can store in a storage service? We can store data which is completely unstructured, and we can also store data which is partially structured. Of course, we can store data which is structured, but for structured data, it is preferred to have something like SQL Server or SQL database service. Only when the data is unstructured and you might have partially structured data, you should go for SQL storage service. Now, what is unstructured data? Something like a flat file. Say for example, I have a Word document, or I have a PDF, or it can be image, GIF, PNG, JPG, any kind of image. It can be a log file, pretty large log file, or it can be a virtual machine disk, or it can be any MP4, MP3, any kind of file whose data is in binary form. Yes, we can store that in a storage service. So most of the times what happens is when an application requires, let us say, a registration form, we will let the user to fill the registration form and store the registration form details in SQL database. But if the registration form requires his photograph or some identity documents, we will store those documents in Azure storage, and the URL of those documents in Azure storage, we will save them in SQL database. So like that, yes, we are going to use SQL storage as well as SQL database both in our modern enterprise applications. So that is example of unstructured data. Now what is partially structured data? See, whenever we are dealing with a table, something like SQL database table, we are going to have fixed number of fields in that particular table. and for those fields every record is going to provide value. So if I want to store employee details, I'm going to have employee ID, employee name, employee salary, maybe age, qualification, address, blah blah blah, fixed columns. And for every employee we are going to provide these columns and there is no ambiguity. But there are cases where in practical you would not know what are the fields you may want to store in the database. For example, now imagine I am dealing with an e-commerce project. And in the e-commerce project, we are going to have various categories and every category is going to have a lot of products. We have categories and we have products. Now for every category, the products which are available are going to have different description, different attributes. For example, if I have furniture category, the set of fields, attributes are obviously going to be different from the pets category. So in pets, when I'm going to store cat or maybe dog or maybe a parrot or maybe a fish, I would probably store different fields. And in furniture, where probably I'm going to store chair, table, those kind of things, I would store different fields. So when the fields are different, can we create different tables? Yes, that can be obviously a choice. So I would go for, let's say, furniture as one table. I would go for uh, pets as another table, electronics as another table. But there comes a limitation. We cannot create a new database table for every new category which we want to support. So what is the choice then? We want to store all the categories dynamically. We should be able to add new categories. Dynamically, we should be able to set attributes which we are going to have for the products of that particular category. So how are we going to manage all these things? Basically, we want a provision where at one place we should be able to store multiple entities and these entities may not have same fields, same description, same metadata. And precisely for something like that, we are having storage account table. See, we are going to elaborate more, but when I say partially structured data, what it means is, in one place we want the ability to store multiple entities and every entity is supposed to be described through different fields, different properties. That is what we want to achieve now. So that is partially structured data. So I hope it's clear that you understand now what is unstructured and partially structured. And of course, structured is what is as SQL table. SQL storage is massively scalable and elastic. Now what does this mean? You can store hundreds of terabytes of data. You can actually store up to 500 terabytes of data in an SQL storage. 500 TB is pretty huge. And maybe over a period of time, Microsoft might expand that also further. So if you are dealing with big data scenarios, if you are dealing with high volume data, which is a requirement in scientific applications or financial analysis applications, if you are dealing with applications which would store media files, MP3 files, MP4 files, yes, storage is the ideal choice for storing all those documents or files. And the beautiful thing is, not necessary storage should be used only for large and high volume of data. You might be a startup organization. Today you might have small volume of data, but gradually you know that that is going to increase over a period of time. So yes, storage gives you the ability to start with small amount of data and it is only going to bill you for the data which you are going to use. For the amount of volume which you are going to use, only for that you are going to get billed. You will not be billed for everything. That's the beauty of the storage account. So start with few KBs probably and you might probably continue with even MBs and TBs of data, GBs and TBs of data. Storage is having a limitation of 100 storage accounts per subscription. One subscription of Azure can get you 100 storage accounts, and of course each storage account can get you 500 TBs of data management. So 500 into 100, you can just think like that. So, and in that 500 TB, of course, you can store blobs, queues, tables and file data, which are actually 4 different types of storage services. We'll talk more about it. But as I said, the beauty of the storage is it can grow on demand. It automatically allocates to you the space required, and we are only charged for what we use. So, conclusion, storage, Azure Storage Service is the best place where the large volume of data is going to be stored in Azure. So now talking about storage account. Now when we create a storage account, we are actually going to create a storage account as standard or as premium account. Standard storage or premium storage. Now what is the basic difference between a standard storage and a premium storage? Standard storage is going to use a HDD drive, simple ordinary hard disk drive, whereas premium storage is going to store SSD drive. Basically SSD drives are considered to be much faster when compared to the HDD drives. So premium storage is very fast when compared to the standard disk. So we have got premium storage ideal for using virtual machines. When we want to have virtual machines and the virtual machine requires to have an application which is performing lot of read and write operations. We want that virtual machine performance to be good. We want better IOPS, input output operations per second. So those kind of cases we go for premium storage. But if you want to store simple blob, table, queues and files, we can simply go for a standard storage. So two types of storages, and there are 4 types of storage services. As I said earlier, blob storage is for basically storing any kind of data. It can be binary data, it can be text data. In short, any kind of document, any kind of file, you can store it in a blob storage, and these are referred as object. That's why blob storage is also referred as object storage. Both are same, blob storage, object storage. Then we have got table storage. As I told you before, it's best for partially structured data set. In one single table, we want to store entities of different types, and each of these entities are going to have columns, fields which are not necessarily same, which can be different. I'm going to elaborate more of it later, but yes, that is the table storage right now. In short, these kind of storages are referred as NoSQL key value pairs. Mostly they are internally stored in JSON format. They are pretty fast to read and can easily manage large quantity of data. Queue storage is something very special. It's basically for reliable asynchronous messaging. Whenever we want two applications to exchange data, there are actually 2 ways of doing it. We do it synchronously. That means application A says hello and application B listens to the hello at the same time and picks it up. That means both are live at a time and there is a direct data exchange happening between them, direct dialogue happening between them. So that is one form of communication. We call it as synchronous communication. Then there is asynchronous communication, where application A is not necessarily live when application B is running, or vice versa. That means both of them may not be running at the same time. So in those kind of situations, application A is going to post a message into queue. The message is nothing but some kind of data which is made up of multiple fields again. Let's say some object. That object I'll put it into the queue. Application B, whenever it wakes up, it will pick up the messages from the queue and will start processing one at a time. This is really very helpful, especially in situations where the performance of application A and performance of application B is not in sync with each other. Maybe one is faster when compared to the other, and most importantly, it is a reliable messaging because all the messages will be there stored in the queue, and it is assured that all of them will be processed one after the other in sequence. Nothing will be lost. So queue is also one of the feature of Azure storage, which is very useful in real-time application programming. Yes, there are alternatives, like for table storage we can use Cosmos DB. For queue storage we have got Azure Service Bus queues. Those are better and more modern ways of doing it, but they are also pretty expensive. We get in those Cosmos DB or the Service Bus extra facilities we are going to cut, but they are little expensive over the table storage and queue storage. Then we have got file storage. File storage is exactly similar to that of blob storage. Here also we are going to store files only. But the basic difference between blob storage and file storage is blob storage is a flat architecture. That means we do not have directories and subdirectories in the architecture of blob storage. Blob storage simply store files at the same level. It's not hierarchical. Whereas file storage gives you the ability to store files in a hierarchical form, basically folder, subfolder, sub-subfolder, like that you can store it. Anytime blob storage is much better when compared to using file storage for the benefit of performance and cost. File storage, as I see, is at least 3 times expensive when compared to blob storage, more than 3 times only, not less than 3 times. Then why is file storage used? You might have lot of legacy applications which are already developed using file system. That means you have programmed it using C colon in mind, D colon in mind, some drive path you have kept in mind and you have programmed it. The same program will not work with blob storage because the API to work with blob storage is different. So in those kind of cases where we want to migrate our legacy applications from on-premise to Azure and we do not want to make any changes to the code, we want existing file system code to as it is work, then in those kind of cases it becomes mandatory to use file storage. We cannot use blob storage. So yes, for traditional applications we want to make use of file storage. So these are the 4 different types of storage services and we are going to focus one at a time on all these 4. One after the other we'll cover one by one. So just a summary here. You have got a storage account. In storage account we are going to create blob storage for which we need a container. We are going to store entities for which we need a table storage. We are going to store messages for which we need a queue. We are going to store files and directories and of course a hierarchical structure for which we need a file share. So how are we going to do all these things? Creating a storage account and managing each of these storage services and their security is what we are going to see from next session. Thank you.